We are finding the family of antiderivatives of the function sine of x plus e to the 2x. And finding a family of antiderivatives just means we're finding all of the functions, capital F of x, such that the derivative is the function that we're given. So you might recall that the derivative of cosine of x equals the negative sine of x. And that's great, but our function doesn't have a negative on it here. So what we really want to say is that the derivative of negative cosine of x equals the positive sine of x. And that's great, because for this first term here, we found a function whose derivative is sine of x. Let's write it down. Our capital F of x, our antiderivative of our first term, is negative cosine of x. We also might recall that the derivative of e to the 2x is just e to the 2x times that 2 because of the chain rule. Again, we don't want this 2 here. We want the function whose derivative is just e to the 2x without the 2 there. So we can get rid of that 2 really by dividing both sides of the equation by 2. And then you'll notice that the derivative of 1/2 e to the 2x is just e to the 2x. That is exactly what we wanted for this term. And we can just pop a C on there and we are finished. Of course, it's not a bad idea to check our answers here. It won't take more than a minute. The derivative of cosine of x is negative sine of x. So if we take the derivative of negative cosine of x, we get this extra negative on here. The derivative of 1/2 e to the 2x is 1/2 e to the 2x, and then the chain rule says we have to multiply by a 2. What does that give us? Well, a negative sign is just a sine of x. 1/2 and the 2 cancel, and we get e to the 2x. Oh, again, the derivative of a constant is 0, so that was on there as well. But by taking a derivative, we just got back to the function that we started with, so that's exactly what we wanted. We have successfully found the family of antiderivatives of that function.